Okay, so today, two things to make this really quick. The only new thing we're going to add is we're going to talk about how we write the equations of horizontal and vertical lines. And then I want to just review the stuff we were doing last week, right? So what if I give you an equation like this? Okay? And they want us to do a couple things. They want us to write the equation in slope-intercept form. From that equation, they want you to determine what's the slope and what's the y-intercept. So part A, once that's done, part B is just free. And then part C is graph the equation, okay? So remind me real quick, how do we go from our starting equation into slope-intercept form? What's that process? I don't need specifics right now, but what are we trying to do here to put it in? Isolate y, exactly. We isolate y on one side, and then on the other side, what do we do? I mean, yeah, but we're not really solving in this case. We're just writing the equation. On the other side, we isolate y, and on the other side, we're just simplifying it, right? We're just writing it in its simplest form. And if we do that, it magically ends up in slope-intercept form. So let's do that. Let's get one good practice problem in. This is kind of stuff we ended up last week with. So here's the y I'm supposed to isolate right there. Okay, what would I have to do first to isolate that y? Casey, tell me one thing I got to do to get that y by itself. Good, add 56. I want to move that term over to the other side. Good. And I'm going to do that by adding 56 to both sides. What else could I do at the same time? Yeah, let's push the x term, the 7x, to the other side by subtracting 7x. And I have to do the same thing on both sides, right? So I'm going to do the x first, and then the number. And that's good. So we cancel the x's, we cancel the 56, and we just get, whoops, we get 8y equals 0 minus 7x plus 56. Well, that's just negative 7x plus 56, right? We started with nothing on that side, and we end up with that stuff. Okay, last step here. What do we think? Aiden, what would you do next if I'm going to isolate that y? Divide by 8. Good. Last step is divide by 8. Okay, now we got to be careful with this one, though. When we divide by 8 here, how do I do that on the right side? If I divide the whole right side by 8, I get a common denominator, right? Do I want that? I don't want that, do I? Because what I'm trying to do is put this into slope-intercept form. Remind me, what is slope-intercept form again? Y equals, equals mx plus b. Okay, so I want to have separate terms there. I don't want a common denominator. So when I divide by 8, how do I do that? Divide each one separately, right? I don't want a combined denominator. I want separate denominators. So I'm going to divide each of those terms on the right separately by 8. And that's good, right? I cancel the 8s. And so I get the equation. Starts off y equals, well, that's good. Okay, what do I do with that first term on the right side? Okay, good. I want whatever's being multiplied by x, and if there's a denominator, I want all that stuff grouped together into a fraction, right? And it may not be a fraction. If I have a 1 on the bottom, I don't even have to write it as a fraction. But in this case, I do have a denominator, right? So that's going to be my m, right? Because that's what's in front of the x. And so what do I get for m? Negative 7/8. If there's a negative, it always... Now, the way they write this is fine. They wrote this as negative 7/8. That's fine. But when I think of this as a slope, where am I going to put the negative? On the top or the bottom of the fraction? Always on the top. Good. You guys got this. So negative 7/8 x. And then the last term, I'm just going to simplify that. Just reduce the fraction. What's 56 over 8? Not 8. 7. There you go. Good. Okay, so this just becomes... Oops, that's not what I wanted to do at all. That's what I wanted to do. So all that stuff is just going to become my b, which is 7. Okay? All right, so then from slope-intercept form, this is a freebie. What's my slope? -7/8. Yeah, now, I don't like the way they wrote it. It's okay, but what should we do differently there, probably? What am I going to do? Where's the negative sign go? On the top. Yeah, so we probably want to write this instead. Let's write this as our slope here is -7/8. And remember why we do that. It's really important you remember this. The reason we do that is if the sign of the slope always goes on the top, then the rise could be positive or negative, but the run is always positive. So when we make our slope triangles, we're always going to go to the right horizontally. And there's no confusion about that. Sometimes that causes confusion for people. And then what's the y-intercept? 7. Absolutely, it's 7, isn't it? Okay. Good. So we have a slope of -7/8. We have a y-intercept of 7. And we always graph lines the same way. We just need to get 2 points and connect and extend. Well, how do I get my first point here? Y-intercept, right? That's a free one. I know the y-intercept is 7. I go up on the y-axis 7. And then how do I get my second point? Okay, yeah, I'm going to make a slope. What shape again? A slope triangle, right? And the reason it's a triangle is because I'm always going to go vertically and horizontally to create 2 legs of the triangle. And then the other leg is going to be the line itself, right? Okay, so we're going to go, what does it mean to have a rise of -7? Down 7. And a run of 8. I go to the right by 8. And I get my point right there. And then now the technology will do this for you. All you have to do is just connect and extend, and we got it. Okay? Give me 1 to 5 on that. Outstanding. Okay, good. So for today, minor stuff. All we're going to talk about is horizontal and vertical lines. It's going to take about 2 minutes, 3 minutes. What do you notice here? I've got a vertical line graphed, a red vertical line. What do you notice about every point on that line? There's something important going on. What do you think, Bandry? The x-coordinate is always the same. The y-coordinate could be whatever, but the x-coordinate is always the same. So the math gods in their infinite wisdom don't even care about the y here. It's not important. If I want to graph that line, I don't even need to know specific y-coordinates. All I need to know is that all of the x-coordinates are -3. And that makes it easy to graph, right? All I have to do is pick any 2 points in the xy plane with x-coordinates of -3 and just connect and extend it. I'm going to get a vertical line. So what do you think the equation of that line is going to be then? What's the easiest way to name that line? Because the math gods are going to do it the easiest way. Okay, yeah, but if I had to come up with an equation of the line, let me be more specific. X equals -3. You got it. That's it, right? That's all I have to do is write x equals -3 because that is always going to be the case for every point. Okay, how do you remember that? Here's an easy way to remember it. A vertical line cuts through which axis? A vertical line cuts through the x-axis. Okay, so a vertical line cuts through the x-axis. So the equation of the line is x equals whatever the x-coordinate is of every point, including the x-intercept. You could even just look and see where it crosses the x-axis if you want to. Any point will do, but that's a pretty convenient one too, right? Well, we're going to take that same reasoning for a horizontal line. What do you notice about a horizontal line? The y-coordinates are all the same. It doesn't really matter what x-coordinates I pick. The y-coordinates are always going to be 1. Okay, so if that's the case, a horizontal line cuts through which axis? The y-axis. And how do you think I'm going to name a horizontal line? y equals whatever the y coordinate of every point is, including the y-intercept. Y equals 1. Give me 1 to 5. So those are super easy. You just got to remember that trick. So let's just try 2 of these real quick. Write an equation of this line. Okay, well, they tell you something really important here. They tell you that the slope is 0. What does that tell you about this line? Show me with your arm, what does a slope 0 line look like? No, not this. This. How come horizontal? Because what's 0 in that fraction, the rise or the run? The rise. The top of the fraction is 0, right? The rise is 0. So 0 divided by the run is just 0, right? Okay, so we know that this is going to be a horizontal line. So how am I going to name it? A horizontal line cuts through which axis? The y-axis. So what do you think? Y equals... Well, no, look at the point it goes through. Y equals -5. Okay, you could do this. Well, we'll come back to this one later. There's another way to do this that we'll learn in a little bit, but later this week. But that's the easiest way, is just to recognize the key hint there is that if the slope is 0, it's horizontal, so it's easy, right? Horizontal lines intersect which axis? The y-axis. And the y-coordinate is -5 of a point on the line. Okay, how about this one? We're not going to, okay, I mean, it says standard form, but the form is irrelevant. If you're writing the equation of a horizontal line, whatever you want to call it, standard form, it doesn't matter. It's just what? A vertical line. They tell us it's a vertical line. So how is that equation always going to start? Vertical line cuts through which axis? X-axis. So x equals what? -4. Whatever the x coordinate is of any point that's on that line, and we got it. 1 to 5. How we doing on that? Okay, go to work. I'm done.